Betsy's Corner, we're going to solve compound inequalities. Well, what is a compound inequality? Well, it's two or more inequalities that are connected either by the word and or. So we have two types of compound inequalities, which we'll look at today. All right, so the first example says, how can you use inequalities to describe the set of numbers graphed below? All right, so if we look at this first graph, we have -3 and to the left. So that's x, right, is less than -3. All numbers that are less than are equal to -3 because we have a closed circle there. Okay, or we're going in this other direction. X is greater than 2. Now, we don't have that equal sign there, right, because we talked about that before. That's an open circle. Okay, so that's our final answer. It's one or the other. All right, let's look at our next one. This time we have numbers that are in between, right? They're in between -4 and 1, and we're including -4, but we're not including 1. So those numbers we're going to use, that's going to be our variable in the center, okay? So because that's a closed circle, we're going to say -4 is less than or equal to x, and x is less than 1. Okay, so this is our final answer here. So we have two things going on. That's why it's an and. We have our number has to be greater than or equal to -4, and it also has to be less than 1. Okay? All right, let's look at our next one. Solve the compound inequality. So when we see the word or, we're basically just going to solve these inequalities separately, and then we're going to see what happens when we're all done. We're going to put the word or between. So in the first one, I'm going to subtract 8 from both sides. So I have 4n is less than or equal to 8. Divide both sides by 4. So n is less than or equal to 2. I'm going to use that word or, and I'm going to come back to that. I'll solve the other inequality. Subtract 7. So I'm left with -3n is less than -18. Divide both sides by -3. Now remember, when we divide or multiply a negative number by a negative number, we're going to change the direction of the sign. So our solution set here is all numbers less than or equal to 2 or the numbers that are greater than 6. Okay, so we have a closed circle here to the left. And then at 6, we have an open circle to the right. Okay, that's where our or is. It's one or the other. All right, let's look at our next one. Now we're going to include some ands. So that one was or, where we're doing one thing or the other. Now we're going to do some ands. So if we look at example 3, I have almost 3 sections, okay? If you notice here, I only have a variable in the center. Variable in the center. That's it. So when we have that, we do want our variable to end up in the center. And we're going to divide in 3 sections. So basically, I know when we have an equation, usually say whatever you do to one side, you do to the other side. The same holds true, but this time it's going to be 3 different sections. Whatever we do to one section, we have to do to the other 2 to still to keep it balanced, right? That inequality balance. So I want to get the x by itself. So the first thing I'm going to do is I want to get rid of that 9. So I'm going to do the opposite operation. And I'm going to subtract 9. I'm going to do that to all 3 sections. So that leaves me with -21. I have 7x in the center, and then I have 7 on the right. So now I'm going to divide by 7. Each of the sections, right, this is going to come down, each of the sections by 7, and I end up with -3. I'm going to use the symbol that was given, less than or equal to x, which is less than 1. Okay, so that's going to be my final answer. So x has to be between, again, this is an and, because we have more than one thing going on. X has to be greater than or equal to -3 and less than 1. So that solution set, we're going to put a closed circle here and an open circle above 1, and we're going to connect it. So all those values in between are part of my solution set. All right, let's look at the next one. Again, I'm going to kind of draw my walls. I notice that I just have one variable in the center. So I'm going to get rid of my 4 in the center. I'm going to add 4 to all of the sections. And I have 0, and then I have -x, and I have 5 over here. Okay, now I don't want -x in the center. I want x. So I'm going to divide everything by -1. Now remember, when we divide by a negative number, we change the direction of the sign. So before I do anything, I'm going to look back to my original problem, and I'm going to change the direction of the sign. Okay, 0 divided by -1 is 0. That's going to give me x in the center, which is what I want. And I have a -5 over here. Okay, we always want arrows pointing to the left. Arrows point to the left. Okay, that's going to be the easiest way to read it and how we see it usually on multiple choice tests. So do you see here my arrows on the right? So I'm going to have to relabel that. So I'm going to kind of switch the order. My -5 is going to go to the left. My X is in the center and my 0 is to the right. If you notice when we do that, it's going to match up where things are on my number line. My -5, which would be here, is definitely to the left of 0. So it's kind of an easy way to do it as well. We want to put it in order of the number line. Now, in this relationship, we're pointing to the -5. And in this relationship between 0 and x, we're pointing to the x. So that's going to be my final answer. -5 is less than or equal to x, which is less than 0. Okay, so now I have to graph it. Close circle above -5. So I'm including -5, open circle over 0, and then it's my barbell in between. Okay. All right, let's take a look at the word problem here. We have Enrique plans a diet for his dog, River. So River is the dog. Got it. River consumes between 510 calories and 540 calories per day. So what I'm going to do is I'm going to put the 510, that's the low value. 540 is on the right, that's the higher value. Now let's see what's going on. If River eats 1.5 servings of dog food, okay, so this is the dog food here. It just kind of has a nice picture for you, a visual. And then this is the treats, right? So we're going to let X equal the number of treats. Because if we keep going, it says, how many treats can she have? So our unknown is going to be our variable. So that's our X. Okay. And the question is, how many of these treats is she allowed to have? So let's see what's going on. So between the 510 and the 540, we got dog food being eaten and the number of treats. Okay, so we say the dog food here is 320 calories per serving, and he eats 1.5 servings per day. So I'm going to put 320 times the calories per serving times the 1.5 servings she eats per day. Okay, now we also have the treats, and the treats are 15 calories. So we're going to add 15 calories times the number of treats. Okay, now when we do inequalities, we're going to put our arrows to the left. Now, River is allowed to have between 510 and 540, including those numbers. So we're going to have 510 is the least and 540 is the most. So whatever's going on in between here has to be between 510 and 540. Okay. All right. So let's see what happens. So what I'm going to do first is I'm just going to rewrite that 510. And my symbol, 320 times 1.5, that's going to be 480 calories plus the 15 calories per treat. We got to figure out how many treats that dog is allowed to have and still stay within the calories allotted. Okay. So now again, I have one X in the center, so I can do my different sections like we did above. I need to get that X by itself. So the first thing I'm going to do is I'm going to subtract 480 from all my sections. And I'm left with 30. And I have less than or equal to, right? I'm going to just bring that sign down. I have 15x here. Again, bring that sign down. And 540 minus 480 gives me 60. Okay. And again, now I need to get x by itself. So I'm going to divide every section by 15. So my inequality is 2 is less than or equal to x, which is less than or equal to 4, right? That's my next step. Now, X was the number of treats. So because the question says how many treats can she have, River, which is our dog, can have, right? We have between 2 and 4, can have between 2 and 4 treats. That's how many treats the dog can have and be within the calorie limit that was established. Okay? All right, so let's take a look at our last two problems. They're slightly different, so we just want to get practice with those. First of all, you see the word and, so we're going to have an and. So let's go back up. Unlike these right here, they were and, but that was just like one big inequality, right? That's just one big inequality statement. These are separate. So we're going to solve them separately and then see what happens. So I'm going to get that a by itself. I'm going to subtract 13. So I have negative 4a is less than 16. I'm going to divide it by my coefficient, which is negative 4. Remember, when you divide by a negative number, you change the direction of the sign. Now, so I don't forget whether it's an and or an or, I'm just going to bring that down and I'm going to write the word and so I don't forget. I'm going to do the same thing with my other inequality. So I have 24 is greater than 6a, divide both sides by 6. And I have 4 is greater than a. I like to have my variable on the left, so it's going to be a is less than 4. So we have two things going on here. We have a has to be greater than negative 4 and a has to be less than 4. So the easiest thing to do is line them up like they are on the number line. Negative 4 would be to the left. My variable I'll use is a, right? That's what they give you to begin with. So I am actually, I made a mistake here. I got to go back and fix it. That's a is greater than or equal to negative 4. So in looking at this, I'm pointing to the negative 4. I'm going to point to the negative 4. Right here, I have a is less than 4, so I'm going to slide that in. Okay, so this is going to be my final inequality here. So let's just see what happens. Two things are going on. That's why I have an and. So a is between negative 4 and between 4. I'm including negative 4, but I'm not including 4. Okay, so basically I took what was written. I made one inequality so that I can graph it. So I have a closed circle over negative 4, an open circle over 4, and the kind of the barbell in between. So I'm including all the values. Okay. All right, let's take a look at this last one. Now, when I look at this last one, I do notice that I have 3 sections, right? But when I get started, I'm like, wait a second, I have a variable in each of those sections. So I can't kind of follow the same rules that I did in the past, right? That was only if there was a variable in the center. So what I have to do here is I'm going to have to separate them. When there's more than one variable in each of the sections, right? I'm going to split them. So I'm going to put this inequality first. 3b plus 2 is less than 5b minus 6. And then I'm going to rewrite this inequality. So I have 5b minus 6 is less than 2b plus 9. Okay, now again, I have a lot going on there, but I know that's an and statement. So I'm going to separate them first into 2 separate inequalities. I'm going to solve for a b on both sides, and then I'm going to combine it like I did in the last one. So this gives me negative 2b plus 2 is less than negative 6. Again, I'm trying to get b by itself. I'm going to subtract 2. So I have negative 2b is less than negative 8. I'm going to divide by negative 2. Now, again, I divided by a negative number, so I'm going to change the direction of the sign. So I have b is greater than 4. And I'm going to write the word and so I don't forget. Do the same thing with this other inequality now, right? So again, I'm going to try to get b by itself on the left. So that gives me 3b. I'm going to add 6. This one, I'm going to kind of do it all in one step. So that's going to zero out. And I have 3b is less than 15. Divide both sides by 3. And I want to get b by itself. So that gives me b is less than 5. Okay, so this is what I have here. But now I wanted them to put them in one statement. Okay, so when I put it in one statement, again, I think the easiest thing is to put them in order as they would appear on the number line. So 4 would be to the left, 5 is to the right. I'm going to put the b in the center. Now, my relationship between b and 4 is I'm pointing to the 4. My relationship between b and 5 is I'm pointing to the b. So again, both arrows are to the left, so I'm okay. So this is going to be my final inequality statement. So now I have to graph it. So I have an open circle above the 4 and an open circle above the 5, and I have my line in between my little barbell. Okay? Thanks so much for stopping by today. You have a great day.